morning, everyone. Happy Webinar Wednesday. My name is My-Linh Truong. I am the Division Manager for Unmanned Laser Scanning at RIEGL USA here in sunny Florida. Not to rub it in for those that may have not so great weather wherever you are. Thanks for joining me today and for your interest in joining me on a journey to talk about the benefits of RIEGL's mini and mighty UAV LiDAR technology. So let's dive in. So for those that want to empower your mind and expand your knowledge base on RIEGL UAV LiDAR, today's webinar will highlight really targeting your needs with multi-target return capability for those that may not know what that means, how to streamline your UAV LiDAR operations with our technology. We're going to unlock what RIEGL's RiLOC-E is, and taking it further and beyond with NFB laser scanning. Now, for those that have questions, we'll take some time to address those in the end of today's webinar. So if you have any questions, please feel free to type that into the questions box and we will get to those, as many of those as we can. And then if we can't, then we will definitely address those via email afterwards. So what is multi-target return capability? Really, the benefit is vegetation penetration, multiple returns per laser pulse, which is beneficial. You're not just getting the top, first return, top of the tree canopy. You're able to then get through the vegetation all the way to the ground and expanding that further to create your dense point cloud to either identify that vegetation or take it out and get to the bottom to get that terrain and create your contour lines depending on what your application is. So if we dive in and take a look a little bit more at an actual point cloud here, you can see that this is a pretty vegetated area and we're not just getting the top here colored by height. You can see the top red canopy there as the terrain is undulating in this little hillside here. But you're able to identify all of those tree vegetations and you're able to penetrate to the ground, which means that if you take that vegetation away, we're able to not only identify just vegetation in general, but the nuances of that. So not just the trees, but also there is some shrubbery, some medium vegetation, some other plants, fauna underneath, able to even identify that there's deadwood under this forest. And then if you take that away, you're also able to create your DTM from the ground return. So this is really beneficial just from your terrain, capturing it with the LiDAR. So diving in further, when you're actually capturing data with your UAV-based LiDAR system, it starts with planning. I mean, you're not just going to go out in the field and just turn on the system and just go and hope for the best, right? You're going to plan, you're going to get on site. Before you get on site, plan accordingly. And when you want to plan for is your mission. And then using the parameters of that mission, you can use RIEGL, which is our free software. And then you can toggle based on your scanner type, the laser pulse repetition rate of the options for that particular scanner and scale it accordingly based on your AGL and the area and make sure that you're capturing the point density that you need to collect that information. You can feed that into RIEGL Embedded, which is our onboard embedded acquisition software for all of the laser parameters that you've determined from RIEGL. Enter that in with the camera information as well, if you have a camera coupled with your system, and then you can enable whether you want to automatically collect the information upon startup or remotely control it using a PWM trigger to actually specify these are the flight lines that you want to capture and toggle on and off. Once you have your pre-flight mission, you get on site, you're turning on your system that will do your configuration checks in RIEGL Embedded. You can view the inner web interface. We'll see that a little bit later in today's session. And then depending on your sessions, the scanner will start automatically and then capture your mission. So take off, initialize the IMU, do your kinematic excitement, capture your mission, land, and then it'll automatically shut down the system after the pre-planned time for that static alignment. And then with your post field, you're able to then again also check your mission via the web interface on RIEGL Embedded, make sure everything's toggled, turned off, you got everything that you need, and as mentioned, it will automatically shut down after you've landed. So from acquisition into processing, we're going to then take your data off of the scanner. You can load that onto your server or the cloud, depending on which way that you're operating. And then the RIEGL embedded project file will automatically open in RIProcess. So again, acquisition or acquire to processing. And then this is where the magic happens. With your data processing wizard, as we call it in RIProcess, you're able to then bring in your process trajectory file, or just import that in. And then you're able to then take that processed file, register your data through RIUnite georeferencing. So you're able to align that all together. You can see your point cloud. You can refine your point cloud by bringing in ground control objects. You can align that using RIPrecision to precisely align everything. You can colorize your point cloud. You can even classify your point cloud. And then when you're ready to export that information, so that way when it leaves the RIEGL environment, it is a fully calibrated, georeferenced, optionally colorized point cloud. You can then export that out via an LAS file. You can export that out with the RIEGL database file, that you can bring that into other RIEGL software such as RISCAN Pro, which is our terrestrial data processing software. You can align that with for data fusion within the RIEGL environment. Same with the camera information, various files for your georeference camera imagery, and then you can even export that into a few different software formats that will load directly into, say, Topodot as well as Terraphoto. So that is it in a nutshell as far as the overall workflow for your third-party then extraction moving forward. But let's dive in further on really what does that mean. So in this case study, we have a local calibration field that's about 60 acres. And you can see that's why it's an oversaturation of ground control points here. It's pretty flat terrain. There's some vegetation, there's a little bit of water. Because this is also a flying field, we have a runway here, so some flat surfaces, some building structures for shade. And in this 60-acre field, setting up our UAV only takes about 5 minutes to get everything squared away. This entire site takes 15 minutes to scan. You can fly, of course, faster and scan it even less time. But even then, with the LiDAR system, we've aligned everything together, and this was captured with the Minibux, for example, and the accuracy is tied down to 1.5 centimeters. Scaling it even further for even a larger site, quite larger, 2,800 acres. Again, setting up the system only takes 5 minutes. And then for this particular project, the client that operated the Bucks system was able to tie it down to an average about 1.1 centimeter, so even tighter in tolerance and pretty easy to deploy with that quick setup. So as I mentioned, we're going to unlock the RiLOC-E. E is really for everyone. This economic system is, so LOC stands for Location and Orientation Component, and it is this component that is coupled with our entry-level Minibux series LiDAR system. So smallest form factor with this new RiLOC aspect. We're coupling our own MEMS-based IMU GNSS system, providing our lightest weight UAV system configuration that we've had to date, which is under 4 pounds. and that with this MEMS-based IMU system is fully integrated, and because it's fully through RIEGL, where there's no additional hardware that's needed to be applied and integrated with that. It's even built into our own software package, so you don't even need to do a third-party software for processing your trajectory. It's all within RIProcess. So this is really a perfect entry-level system for just getting your feet wet for UAV operations, and for those that are looking to transition from photogrammetry UAV operations directly into UAV LiDAR. So when I say lightweight, I mean lightweight. This can easily be integrated onto an M600. Well, I said 600 because I'm used to saying that, but I meant M300. It's smaller and lighter, and the UAV system that is in operation. The M300, M350, it's the same kit that can be integrated for the Minivux series, comes with absolutely everything. You can see here we have our Minivux 3 UAV. We've got RILOC on the back of it. We can couple it with the camera, and all of this lightweight can be flown, super easy to use, automatic operation, running on board, and then you can easily toggle on your transmitter for the drone platform, and you can even just toggle on and off the data capture as well. So on RIEGL embedded, using the web interface, you can connect remotely via a tablet, your phone, wirelessly to the payload. In this case, it's on an ACE core UAV, but the same interface would because it's related to the LiDAR system. On that tablet, here is a video of what you're seeing on that device. You can see the serial number information. You can see that everything is green, so all systems are go. You can update information on the scanner if you need to make any adjustments on the fly. No pun intended. And you can make sure you can that everything is logging and capturing the information that you need. It also incorporates MavLink if you want to control that through that remote controller of the UAV system. So it's pretty easy to operate, and then you don't need to connect to the LiDAR system via cables. This is really beneficial when you're out on the field, so you can start and stop on the go. So bringing that in-house using RIProcess, super easy. Bringing that directly into RIProcess, opening the data processing wizard. In this case, the real difference between our Minivux with RILOC and any of our other UAV LiDAR systems, or actually any of our kinematic systems, is that we're able to bring in the raw trajectory file and bring that directly into RIProcess and process it here. So you can add in your antenna, your base station, if there's any ephemeris information. You can even enable RIPrecision to run, which uses the precise information of the point cloud, the surfaces, the control. If you had any control information, bring that in as well. And all of that is going to update and refine the trajectory file, which is then applied to the point cloud through the magic of data processing. Here you go. You can see that this point cloud with the Minivux 3 UAV. And here we are cutting a cross section over this area. You can see that it's just one mission that we have truncated in a few different flight lines. And you can see that here, just taking a pitched rooftop, we're very well aligned. Standard deviation of 1.4 centimeters, which is exactly really what the specs of the Minivux 3 UAV is. And here, pretty exciting. So in another data set that we've flown here is a transmission tower and substation, and you can see that it's pretty well aligned here. This is viewed in scaled reflectance. I personally have not found any in my glance of the data. Haven't seen any differences between the performance of this versus any of the fog type of IMUs. So I think this is pretty exciting for the form factor and the operations of this. So if you want to scale it even further, fly higher, faster, capture more data, and be even more efficient in the field, my personal favorite system that we offer is our VUX1 120 system, and we also, and its sister, the VUX 160, a little bit larger, a little bit longer in range in its scanning capability. But the nuances of these two particular systems, I think, is so cool because it offers what we call NFB, which stands for nadir. Here we go. Flying, typical operations, flight direction forward here, you're capturing points on the ground, data on the rooftop of these building infrastructure, the top of the transmission tower. That's pretty standard. But here at forward 10 degrees in the same flight direction, we're also co-capturing points on the ground, the front facade of the building structures, and the front of the side of the transmission tower, as well as backwards 10 degrees, again, points on the ground, the back side of the building facade, as well as the backside of the transmission tower. And all of this is captured in the same flight path, really providing complete coverage on the ground. So taking the LiDAR sensor, taking the IMU, capturing it with imagery, we have quite a few different options. You know, when we see mini and mighty, what are we talking about here? Well, it's not just the UAV or technology, not just the LiDAR technology, not just the IMU technology, but also cameras as well. So everything is getting smaller, lighter. So with the new industrial grade camera from Sony, the ILX R1, LR1, excuse me, this pretty neat with the 61 megapixels stripped down form factor of the same performance of the A7R4. We're getting a 61 megapixel camera and a lighter weight form factor here. And then that opens the doors for more integrations with this open platform configuration. So this mount can support up to 3 cameras at a nadir configuration as well as oblique angles. So for those that are looking to scale up, get alternate system orientations for that and really expand that further on not just a UAV, but maybe also taking that same payload and putting it onto a manned aircraft operations. You can kind of get the 2 for 1. So once you've decided on your UAV LiDAR configuration, you're applying it towards your different applications. Here you can see and apply it just like with NFB. As I mentioned with the VUX 120 and 160, dense capture of the transmission towers, lots of points on the power lines. We can apply that to transportation, flying it off, capturing the right-of-way information. Use it during construction, as-built assessment, quick deployment, capturing the information. Here you're looking at, again, in scaled reflectance, so you can see the pooling, where the storm drains are, very important to capture. Apply it for critical infrastructure inspections with the wide field of view of the systems, able to quickly deploy and capture that inspection for rapid response. Open pit mining, again, the nadir shots, but also the nadir and forward, backward aspect of NFB. We're able to get more of the information in this pit. You can even apply it for geophysical risk assessment and management. It's from threat of landslides, all that, and get the facade and get that information. Of course, there's more applications. So this is just a small sampling. So when you have that information, it can, of course, be overwhelming. So this is just a quick reference guide on really the benefits of really what the difference is between the mini VUX series, the VUX 120 and 160. You'll see something here that I didn't mention yet, which is the VUX 180. Yes, we have quite a lot of systems, a large fleet of our UAV-based LiDAR systems. I just want to quickly mention about the VUX 180. It is the same form factor as the VUX 160. The real difference between it is that it is nadir scan pattern. but doubling the lines per second. So really it's optimized for high-speed fixed-wing UAV operations. Can even transition that to manned aerial acquisitions. As mentioned, the VUX 120, 160, really NFV. Keep pushing NFV because I just think it's so cool. Really just as the technology expands, we're just getting smaller, lighter, just more information on the ground in the form factor. So I just think that's great. And of course, our mini VUX series, which is our lightest weight offering, really with that one-touch approach, processing with RILOC, so very cost-effective. So depending on what you're looking for, we have something for you. So last but certainly not least, stay tuned tomorrow if you can't get enough of our RIEGL webinars. My colleague Tanner Dutton is partnering up with a company called Mach9 and showcasing how to enhance your survey data efficiency by using the AI feature extraction for mobile mapping workflows. So stay tuned. Definitely scan that QR code on screen. If you haven't registered yet, definitely stick around for that tomorrow. And with that, I thank you all for your attention. And let's see if we have any questions. We have a question about our software. So we have quite a lot of software packages with RI in front of it because we like to RI everything. Everything is licensed. We have a few different licensing options for our software. Primarily would highly recommend our serial number based licensing. We call it SNL. And the benefit of that is it's issued per serial number or per serial unit, and then that license key will then unlock processing of data from that particular instrument on any and all computers. You can add that to the cloud, unlimited threads of processing, so very efficient, and that's really helpful for operations, especially with IT infrastructure and companies that have multiple offices that are using information from that particular system. And then as you scale up in your fleet of RIEGL instruments, whether that's terrestrial, mobile, UAV, aerial, all that, the more that you scale in your units, the cost of the licenses per instrument scales down because it's the initial investment and then kind of a automatic built-in discount as you scale up. Of course, if you're looking to start off and you just want to get your feet wet, we also offer our network-based licensing called SIL, and that single instance is that network-based dongle plugged in, and then any RIEGL instrument that uses the processing suite for that, so any of our kinematic software can then be utilized for pulling from that pool of licenses. So that's beneficial as you're scaling up as well. But of course, there is a trade-off with the number of processing tasks that you can utilize for that. I can send we got some pricing questions. So pricing can vary, of course, depending on which instrument type and then system configuration. So I'll reach out to those that are asking about pricing individually. And then another question is on RI parameter. Yes. So RI parameter is a free software utility. There's no license related to that. And that has information on all of our aerial LiDAR sensors, starting from the Mini VUX 1 UAV all the way up to our high altitude VQ 1460 on the airborne side. So all of those instruments are built in, and then per instrument you can select the particular laser pulse repetition rate. You can play around with the lines per second setting. You can set your AGL. You can set the number of overlap. You can even define the aircraft type. So you can, I can't remember how many profile of aircrafts, I think it's like 4 or 5, but you can customize if it's a multi-rotor UAV, if it's a fixed-wing UAV. If you have multiple multi-rotor UAVs, you can really define all the parameters of that, as well as your helicopter or aircraft itself. And then you can play around with the different missions for those different mission parameters for that and see what is the most optimized for your mission that you're about to capture. So for those that have attended, thank you so much for your time today. We'll be reaching out to you all individually to thank you for attending, as well as if you have any further questions, please feel free to reach out to me here via email. But of course, as I mentioned, I'm going to be reaching out to each of one of you individually, and then I'll also be sending out a link for setting up meeting times for those that have one-on-one questions on things that are covered today and expanding on that. So thanks so much, everyone. And again, stay tuned tomorrow.